Hi, everyone. Wonderful to have you here for this session. I'm Alison Bird from Climate Salad, and it's really great to be with you today. Thanks for jumping in. Before we dive in too far, I'd like to begin by acknowledging the traditional custodians of the land on which we're meeting today, which of course is going to be different for all of us. For me, it's the Midgibel people of the Bundjalung Nation, and I'd like to pay my respects to elders past and present, and to extend that respect to any Aboriginal or Torres Strait Islander people who may be joining us today. If you haven't already, feel free to share in the chat your name, your organization or company, and where you're tuning in from. I'm really excited for today's session, which is Climate Robotics Opportunities for Climate Smart Entrepreneurs with Dr. Patrick Meier. Patrick is currently an entrepreneur in residence at the Swiss Institute of Technology and is the founder of the Climate Robotics Network. He also co-founded We Robotics and has served as a fellow at MIT Solve, Stanford, Harvard, Rockefeller Foundation, UBS Global Visionaries, UNICEF Innovations, and National Geographic, and has been a consultant to the Australian Red Cross, Facebook, the World Bank Group, and the European Space Agency, amongst others. And his work, as you can imagine, has been widely published in major newspapers and journals across the world. So we're really honoured and really excited to have Patrick with us today. And he is calling in from across the world, so we're extra delighted to be able to make that work for us. So thank you, Patrick, and welcome. I'll pass it over to you, although there will be plenty of opportunities for questions as well, so do pop any that you have in the chat, and we'll make sure that they get answered as we go. Welcome, Patrick.
Thank you so much, Alison. Thanks for the very warm welcome, and thanks so much for organizing this. I know it takes time and dedication, so I really appreciate it, and great to connect with all of you. I know how busy everybody is, and there's so many things to be doing, so I really appreciate you spending a bit of time with us this afternoon. And I'm here to be as helpful as possible and informative as possible based on your interests, your questions. So feel free to pose any questions, interrupt, ask for clarification, whatever is is going to make this as valuable and insightful for you as possible. I'm more interested in responding to questions than necessarily finishing the deck, and very excited to connect with folks over on your corner of the planet. From some of the discussions I've already had over the past several months, there are some exciting developments across Australia in the climate space, so it's great to connect. Alison very kindly shared my background, so I'll just show a picture of the Swiss Institute of Technology. Invite you all to swing by the next time you're in Switzerland. I can help arrange talks, meetings, connect you with also Swiss VCs, funders, and so on. So that's an open invitation to all of you. And I was born and raised on the West Coast and then East Coast of Africa. And that is important to me because that experience has very much shaped my worldview and explains what I do and how I do what I do today. Right. So, when I talk about or bring up the word climate robotics, I tend to honestly get some blank stares. People don't quite know what to do with those two words put together. And those who don't give me a blank stare tend to say, but we are already engaged in climate AI or AI for climate action, which is absolutely true, right? There is a thriving space around the application of AI for climate action. A lot of energy, some important resources being allocated, some exciting startups as well. At the same time, robotics presents a different kind of opportunity. And I just wanted to spell that out from the get-go before I dive into some real-world case studies to give you a flavor of what kind of robotic solutions are out there and what type of problem they're being developed to tackle in terms of the global climate emergency. So I think, to borrow a colleague's point that he likes to make, is in many respects, robotics is the only way to bring AI into the real world. And one great way to kind of illustrate this point is with the lovable little robot WALL-E from the Disney movie, right? So WALL-E is able to assess and assist in a way that AI alone or disembodied intelligence alone will not be able to. So to give you concrete examples from the real world, This is a robotics recycling type startup that uses, of course, AI, feature detection, machine learning, computer vision, and so on, to automatically identify different types of trash, different types of waste. So that's the assess part of the robotics, but that's only half the picture, right? Because in addition to the assess, the robotics that we're kind of interested in can also assist and actually physically interact with our world. In this particular case, actually then after finding out, what type of trash goes where, is able to then physically change its environment and actually do this kind of sorting that can be extremely helpful and in fact necessary to be able to scale the kind of recycling that we're going to be needing to do more and more in the coming years and decades. So it's about the both and, right? It's about both the assessing and the assisting simultaneously. And in this respect, then, robotics can serve as a bridge between the digital world and the physical world in a way that AI will never be able to, right? That's not a diss on AI. That's just saying there are different strengths and advantages that these different solutions can bring to bear as far as the climate question is concerned. So then what is climate robotics? So if we focus on the robotics part of it, it's really about autonomous robotics, right? Whether these systems fly, drive, swim, or what have you, is kind of secondary. The big deal here is that we're moving from a world that has been characterized by manually controlled technologies to increasingly intelligent and autonomous systems. And the fact that these solutions can assess and assist simultaneously is really key. And I want to underscore that because very often as I'm giving some of these talks to, especially in universities and to faculty, PhDs, postdocs in robotics, they have this tendency to just gravitate towards the assessment, just the AI, the feature detection, the collection of essential climate data in extreme environments, for example. And they don't really give too much thought on the assist side, but that's really where I think you bring the full package together. And of course, climate robotics is about applying these kinds of solutions, ideally in a responsible, inclusive manner for climate action. So let's kind of make it a bit more real now and jump into some examples, right? We know, or I've gotten to learn that over the years that mangroves are climate superheroes. They can capture 4 times more carbon dioxide than land-based trees and plants. The challenge or the problem is that we've lost about half of the world's mangroves in the past 50 years alone, and they're so important to climate mitigation. On the plus side, many communities and projects around the world are actively engaged in mangrove restoration, which is extremely important and inspiring as well. In fact, scientists have identified about just over 10,000 square kilometers of land across the planet that is just perfect, provides the perfect conditions for mangrove restoration. Now, to put that in perspective, you hear 10,000 square kilometers and the equivalent in miles. It's hard to kind of grasp what that might mean. And maybe one way to kind of visualize that might go across borders is thinking of a football field. Well, it turns out that 10,000 square kilometers is about half a billion football fields worth of land that needs to be restored and reseeded with mangroves. And so in that context, then hand planting mangroves, which is 99% of how mangroves are being reseeded today, is only going to get us so far, right? Manual interventions do not scale as much as technology solutions. This is not to suggest that it's an either or. It's always going to be a both and it's not just a scale issue, by the way. Some of these mangrove areas are actually physically difficult to access. You can't walk to them. You'll have to take a boat and try and get around the particular corals and so on. So that's where potentially robotics can lend a helping hand. And that's where a number of different startups, more and more it seems like every month, are actively trying to tackle this particular challenge. There's one Swiss-based startup, Inverdo, that's looking at using aerial robotics, or more commonly called drones, to seed, release mangrove seeds at scale. So this is one of their projects in Pakistan. Last year, you see here their colleagues basically emptying a bucket of mangrove seeds into the drone. and then up it flies, takes off automatically, does its trajectory and flight route automatically, and then lands and releases these seeds in very precise manner. And what I like about this, one of the elements that appeals to me here is that in a way they're recreating what Mother Nature has been doing for millions of years, right? So when mangroves grow and have the seeds grow as well, the seeds become heavier and heavier over time. They snap off the branch and fall into the wet soil, where they hopefully then grow into mangroves, right? So it's about really lending a helping hand rather than, in this case, trying to do something completely revolutionary in terms of mangrove restoration and so on. And what Inverto has been able to show based on actual numbers in Pakistan is when you combine hand planting, as is the case here with their Pakistani colleagues, with drone seeding, you can actually speed up the planting by 200-fold in terms of time, right? So that's something that I think we might need if we're just going to start talking about trying to reseed about 500 million football fields worth of mangrove sites. Now, open question, frankly, is to whether these drone released seeds will actually grow into full healthy mangroves. That remains to be seen. When Mother Nature does it, it's not a 100% success rate either. But what's ultimately really needed is the kind of A/B testing, right? Control study. And there are some developments in the UAE with another, actually an Australian company, I believe, that looks promising. So there are reasons to be optimistic, but I also want to say these are still early days. This is going to be with one type of mangrove in one type of tropical area. Does not mean that the findings there will necessarily scale. I'm not trying to be negative. We just have to be realistic and approach this a bit more objectively and scientifically and see where the data kind of, leads. So that's one example. Another is that until recently, atmospheric scientists kind of ignored the stratosphere as far as the climate crisis. It was long believed that changes in the stratosphere did not actually have any meaningful impact anywhere else. It turns out now in the past few years that based on peer-reviewed scientific journals that have been published, that in fact subtle changes in the stratosphere can lead to and have led to extreme events down on the surface. And so these atmospheric scientists and others who are involved in climate action are very, very keen to better understand that relationship between these changes in the stratosphere and extreme events down on the surface. And for that, they need a heck of a lot more data. This is obviously the consequence of what happens on the surface. Now, the good news is that every year, 600,000 weather balloons, exactly like this one, get launched at least twice a day in 216 countries across the globe. And you see the scientist here obviously holding the balloon with one hand, and in her other hand, she's holding a radiosonde, which is a weather sensor. And that's attached to the balloons that will collect the weather data during ascent. Now, this particular approach, believe it or not, has basically gone, as a process, gone unchanged since the early 1930s, which is when this was started with by meteorologists. And it's got its advantages. That's why we're doing this across the globe. But it's also got a number of disadvantages. When the balloon reaches a certain altitude, like usually around 30 to 35 kilometers altitude, the balloon pops because of the lack of pressure, and the radiosonde drops with a handy little parachute and drifts further and further away. By the way, of course, when the balloon ascends, it starts to drift away from the launch site, right? So long story short, more than 85% of these radiosondes and parachutes end up trashing nature. In fact, most of them end up in the ocean. And there have been studies that show that, yeah, this is having an impact on marine life. So about 51 tons of waste is created every year, and 700 tons of CO2 as well through this particular process, which is obviously less than ideal. So the question is, can we find a more sustainable, reusable approach? And this is what another startup also in Switzerland at EPFL is exploring by developing these self-guided parachutes that can then return the radiosondes to their launch sites. And you see them here coming back to the launch site in Switzerland, not too far away from where I live. So again, exciting. I'm definitely very excited about this personally. I'm in addition to what Alison kindly mentioned, I'm advising a number of early stage climate robotic startups, including this one. And I think there's a lot of promise there. I think there are also a lot of unanswered questions that really need to be figured out, not least the whole business model and so on. So it's not like a holy grail or a silver bullet by any means. Moving over to wind energy, there's some resistance. I wouldn't say significant, but there's some resistance to wind. These massive structures, wind turbines, they ruin the scenery. People don't want them next to their property, fearing property value loss and so on. And so the question is, might there be a way to help extend, augment these massive infrastructure that really are extremely expensive and are complicated to assemble. I mean, I think I just saw some news about one company now trying to build the world's largest cargo aircraft just to be able to transport the turbines from place A to place B. I also understand from colleagues who are in this industry that regulations and the permitting process can be very, very tedious and very long and sometimes uncertain. And then you have the issue of most of the windy sites on Earth being in faraway areas. That means you need to be able to transmit that electricity hundreds, if not thousands of kilometers back to the urban centers, and you have transmission loss, and then you have to use a lot of material as well, right, to bring that electricity back. It just doesn't happen automatically, of course. And so there's a German startup called Kitecraft that's trying to complement, this expansion of wind energy with sort of a hybrid kite drone kind of setup. So here you see the platform has 8 propellers, which uses, and you see it's tethered to a ground station. Uses the propellers to get up into the air, and at a certain altitude can start gliding like a kite, in which case it doesn't need the propellers anymore. And then these propellers basically become wind turbines instead, mini wind turbines. And the advantage there is that you can actually set these up very near urban centers, right? When these kite crafts are up in the air, you don't hear them, you barely see them. I have a video here in a bit just to show you what I mean. And the team is suggesting that the permitting process is far shorter. They use 90% less materials to create these kite crafts, and that their environmental footprint is significantly smaller. So this is not to suggest that these are going to replace these massive wind turbines. There's also just the laws of physics involved in terms of energy production, but it could be an interesting way to augment, and could potentially also scale. Oops. So oh yeah, you can see it all right there. Here, it's not at the full altitude in this particular case, but it won't be the kind of visual pollution that some people are referring to traditional wind turbines as causing. So interesting development. Will they be able to reduce the cost of energy by 2 as they hope to do, and scale? Open question. And this is, again, not a criticism against any of these startups. The fact is the climate robotics space is a new space. And so the evidence base is relatively thin. That's just the way it is when we start out in new fields and new areas of exploration. Continuing on the topic of climate or clean energy, it's all well nice to have beautiful, clean solar panels, but then what happens when they get dirty? We know that the vast majority of solar farms are actually situated in desert or semi-arid environments, which necessarily results in these panels getting dirty. And studies have shown that these panels can lose up to 50% efficiency when they do get dirty. And so when you think you've got 100 megawatt solar farm, one day, 3 months later, you're down to 50. That has repercussions. And in many corners of the world, like here in India, these panels are washed by hand and with serious amounts of water. This is from India's largest solar farm in the northern part of the country in a semi-arid environment. And this water actually has to be trucked in to the solar farm, right, in order to wash the panels. And so you can imagine also local communities that are treating water as a scarce resource, what their potential perception might be, even if that also provides some livelihoods as well. And in this particular solar farm in northern India, you're talking about 10 million panels, right, that need to actually be cleaned more than once a year, ideally. And so manual interventions here, again, just like the mangrove seeding, may only get us so far. Manual interventions and manual deployments do not scale as well. Now, there have been some developments and, of course, progress in this area, trying to basically, speed up the cleaning of the solar panels. But here as well in India, you see this is an interesting, I think, solution in the right direction. But with every row, they have to take this kind of robot off the track, put it in another panel track, and off it goes for another, 1,000 tracks, and so on. Again, it's a step in the right direction. Meanwhile, other early stage climate robotics startups are looking at different solutions, like this particular one, startup called Soltrex. They're looking at using ground robotics, autonomous ground robotics, to clean these solar panels without water, by the way. And so in that sense, it's also more efficient in terms of resources. And in addition, what they're hoping to do is add feature detection algorithms to identify any cracks or deficiencies in the panels in order to help inform and improve preventive maintenance strategies, which is obviously a plus as well if we want to reduce downtime. So we'll see. Again, can they figure out the business model? Can they get the VC funding? Is this really adaptable to different types of solar panel orientation and layouts? Early days. I'll end in terms of examples with one that's closer to your neck of the woods. As I've learned over the years, corals are extremely important. About 25% of marine life depend on corals. So if the corals go, you can understand what happens. And approximately 1 billion people are dependent on the direct or indirect existence of corals through ecosystem services, local livelihoods, and so on. And in fact, just yesterday, today, in the New York Times, on the front pages, there's a piece about, well, unfortunately, more bad news with respect to coral bleaching events across the world. So there's this great story that I've learned. It's more than a story, it's a scientific kind of observation. And again, in your neck of the woods, where just once a year, and it has to be a full moon during a night, there's this magical event that happens when the water temperatures are just right. You get these coral spawning, right? These corals release millions of quote unquote baby corals. Marine scientists will take issue with my simplifying it this way, but hopefully they'll forgive me. It's never been an issue for Mother Nature that the survival rate of these baby corals is extremely low. Mother Nature has already optimized and compensated for that, and it's all good. Until now, of course, when we are clearly seeing corals being under intense stress from the climate crisis. And so now that survival rate becomes critical to try and basically increase if we're going to start regenerating some of these corals. And so luckily, marine scientists are on it, and they've developed ways to basically create baby coral nurseries or kindergartens, which can help then increase the survival rate. But then you have to take these millions of kindergarteners and bring them back into the ocean. And that's where, again, you have that manual deployment that can only get you so far. It's not, again, an either or, we need a both and. And so Queensland University of Technology have been working in this area for years and really pushing the envelope. They've developed a larva bot that they've been field testing, not only in Australia, but in several other countries. And they've shown that by combining human divers with this particular robot that releases these baby corals in areas that are most needed, they can cover 21 more space than if the human divers go at it alone, which is a step in the right direction, right? We want to be able to scale these climate solutions as much as possible. So again, I'm based at a university. How do we spin off the research into successful startups? It's not certainly not automatic by any means, and it remains to be seen who else will get into this space and offer these kinds of solutions in order to drive the prices down. So just to wrap up here and spell it out, the typical reasons for using robotics across industries, not just in the climate sector or in the climate space, is because they can do these dull, tedious, repetitive jobs that are also dirty, literally, and also certainly pose risks to human life and so on. And then, of course, we see a lot happening in industrial robotics and warehouse robotics with Amazon and others because, well, speed, efficiency, and scale is what robotics brings to the equation. Now, in the last point here, I've put an asterisk because the fact that there are labor shortages in certain sectors in certain countries is true, as well as the fact that robotics costs are plummeting in many areas, but it's not true everywhere. Yes, there are massive labor shortages in farming and agriculture. The average age of farmers is continuing to increase because young people have no interest in getting involved, and that's where climate robotics could play also an important role, is in filling the labor shortages and taking advantage of the falling costs of robotics in the process. So in sum, we could try and go this alone. I don't think that we have that much time, but every action does count. So the idea here is that by combining human ingenuity and agency with robotics, we might be able to scale deployments more at a shorter period of time, and hopefully then move the needle on the climate, on tackling the climate crisis. This is not to suggest in any way, shape, or form that robotics is a silver bullet. As we all know, there's no such thing. It's never that simple. And in terms of how to think about this space, I think many, if not all of you already very much aware with this, thinking through the applications around mitigation as well as adaptation, with mitigation being about reducing emissions and adaptation, adapting to the risks caused by the current past emissions. I think there are opportunities for robotics here in both and at the intersection as well. So in terms of the mitigation, as we saw with being able to do maintenance and cleaning of existing solutions like solar farms and so on, as well as extending clean energy through, for example, the Kitecraft wind kite drone hybrid. There are opportunities there. And then likewise on the adaptation side. And now where I'm biased here is I believe there needs to be a lot more attention being paid to the adaptation side of things from a robotics perspective. I think when we look at where global funding is going in climate action, there's, in my opinion and others, those are the opinions of some of my colleagues, who are climate scientists and climate experts, and they believe that there's a disproportionate amount of funding going into climate mitigation and nowhere near enough going into the adaptation side of things. And so I would, if I were starting out looking to launch a climate robotics startup, I would probably start there and look at also the intersection between adaptation and mitigation. And then another area that's going to become increasingly interesting as a space to watch is the intersection between humanitarian tech and climate tech. So I started out in the humanitarian tech space, literally in disaster response, and using emerging technologies to speed up humanitarian efforts. And increasingly, as we all know, the number of climate related disasters is increasing in frequency and magnitude. And so we're going to have these two fields of humanitarian tech and climate tech increasingly intersecting. And I think we need to get ahead of that to help facilitate that collaboration and the exchange of best practices and lessons learned. So climate tech or any tech obviously won't save us. It's a lot more complicated than that. As soon as you take any technology out of the lab, it's no longer a technology problem alone. It becomes a problem of society, environmental impact, inclusion, diversity, local knowledge, sustainability, and so many other challenges. And I'm not going to have time to go into all of them right here, There are many, many, many. And I'll point you to a white paper shortly where we go into these. In fact, the largest section of the white paper is specifically on the challenges. On the plus side, before I unpack a couple of these challenges are frankly no different to the challenges we face in the humanitarian technology space for 10, 20 years. So it's not like we're coming at these challenges completely new without any best practices, lessons learned, and plenty of failures along the way, which is yet another reason why we would want to help facilitate more communication between the climate tech space and the humanitarian tech space. I'm a big fan of this idea of right to repair and repairability and maintenance. If you are deploying robotic solutions halfway across the planet and they break, because we know that Murphy's robotics is not immune to Murphy's law, and you can't, and the folks, your partners can't repair, your clients can't repair these technologies themselves, that creates dependency. It creates an interruption in business operations. Nobody wins. That's not a good thing for anybody. So I just wanted to highlight that. Plus, what is the net climate impact of deploying climate robotics? Just because we're talking about using robotics for climate action doesn't mean we're off the hook in terms of the whole life cycle assessment of our work, right? There's, of course, now lots of talk and a ridiculous amount of money going into humanoid robotics, right? And it remains to be seen where that goes. A good colleague of mine who's a VC, 6 months ago told me, yeah, humanoid robots, it's just hype. Last week, he told me, now it's interesting hype, but he still doesn't, really, is not fully convinced. But in any event, you're seeing some of these startups saying, oh yeah, we want to create, humanoid robots at the 1 billion unit level. What is the actual net climate impact of that? It's staggering, right? It is massive, which is also why I'm increasingly interested in this idea of embracing a minimalist approach to climate robotics. What are the least amount of energy, the least amount of parts and components and materials that we need in order for a particular climate robotic solution to function in a way that's robust and effective. And of course, the software side has been exploring this a lot longer than the robotic side. I think we should be hopping on that bandwagon and really starting to ask ourselves some questions around what are the design priorities when we start thinking about designing and deploying these robotic solutions. And then one last bit is to say, as we see more and more climate robotic solutions being deployed, we're going to, and robotic solutions in general being deployed, these robots are going to occupy more and more of our public and private spaces. So why not bring a little joy with that, right? Why not bring some design and graphic design and art into the design process, right? So this is a great concept from some designers who were looking at this idea of, okay, autonomous cleanup robots that basically pick up trash in the streets. And they were saying, why not make it look like a little maybe family of ducklings, right? That would put a smile on people's faces. The kids would potentially just follow these robot ducklings and also help pick up trash and so on. So again, it might be in a way a small thing, but I do think that it's actually far from that. I think we need to start thinking about this as an opportunity to elicit some kind of behavior change, not based on false premises, but I think there's a lot of value in thinking through these opportunities and bringing different disciplines together around the design of robotic solutions. I'm not going to get into this in any kind of detail. I'll share my slides, but of course, just because we're talking about robotics doesn't mean that all the best practices in terms of startups go out the window. Yes, the hardware is hard. I would say hardware is hard. Robotics is even harder. Now, not all VCs agree with me. Some of them are really actually completely of the opposite opinion. Having always been on the deployment side of robotics for the past almost 13 years now, Murphy's Law is very real. And I think it's one thing to look at basically deploying a more simple kind of mechanical hardware solution. It's a whole other can of worms in deploying autonomous robotic systems. In any event, you start with a problem, you start with the problem owners, and you always go from there, right? Just because we're talking about robotics doesn't mean that all these best practices go out the window. I know I'm probably stating the obvious, but I think it happens to the best of us when we get excited about technology's potential. We tend to then, skip ahead a bit too quickly, and then we're. And this is especially true in terms of maybe at universities, including the one that I'm at right now, where students, postdocs get excited by the technology and, of course, the scientific journals and publications, and assume that their technology is going to be in demand. And lo and behold, a year and a half later, oh no, nobody wants this, right? Let's try and not have that continue to happen. It's a waste of time and resources. All right. In closing, speaking of resources, there are a lot more resources available online at the Climate Robotics Network. We have, like I mentioned, a white paper that is an open working draft right now. So we're actively inviting feedback. It's not going to be, we don't claim that the draft is perfect. We believe it takes a community to do the kind of peer review and to fill the gaps and make the corrections. We've also got an upcoming online summit, an international summit during the first week of May. So that's just around the corner that you're all very much welcome to join. And then also a global map of climate robotics. Who is doing what, where, how, and why in the climate robotics space. We've got about 230 or so different startups that we've mapped. It's an ongoing process. Feel free to add yourself to the map directly or to ping me at any time if you have any questions about the map. And thanks for your patience. Looking forward to any questions, discussions that we can have now.
Thanks, Patrick. I have so many notes, and I know that I have a few questions, but we have in our audience today, I know that there are lots of founders of climate robotic companies, and by the sounds of it, there are a few ideas that have bubbled to the forefront as well based on your presentation. So if you've got any questions, feel free to pop them in the chat or put up your virtual hand. I can't see everybody, but you can also give me a wave if you've got a question. But in the meantime, I do have a couple of questions up my sleeve as well. I'm curious, you've mentioned kind of responsible use in passing. I know that you've kind of hinted at that as well with those kind of humanoid elements. But I'm curious, how do we ensure the ethical use of robotics in these sensitive environmental settings?
Yeah, really great question. I'm glad we're starting with the easy ones.
It's a can of worms.
No, it's really, really important. And one of the things we want to do with the Climate Robotics Network we started, it's far from perfect, is create a code of conduct for the design deployment of robotics in climate action. Now, and the reason for that is because this has worked really well in my previous life in the humanitarian technology space when we created a code of conduct for the use of drones in humanitarian action, which then became the gold standard that the UN started to use and others. And I think, of course, there are questions around enforceability and so on, but I think already spelling out the do's and don'ts as a community of practice is a first step to holding at least ourselves accountable and each other accountable if the policy regulatory side is not quite there yet, right? So I wouldn't underestimate the power of a community-driven, community-developed code of conduct. And then, yes, then you do need enlightened, bold policymaking. And that can never, no amount of technology will completely or partially substitute for enlightened leadership. And I think we have to keep asking ourselves these questions around the risks, right? In humanitarian settings, we would always do a threat and risk mitigation analysis before deploying new humanitarian tech in conflict zones or in the wake of earthquakes or typhoons and cyclones. And I think that kind of practice we need to be able to adapt and adopt in the deployment of climate robotic solutions as well. I think that's extremely important. And then the last point I'll say on this is, at the end, my default is always local communities, those who are either meant to benefit or going to be affected in any way by these technologies. They should have the final say in terms of whether that's being used in quote their backyards or not, right? So the importance of informed consent which is critical in humanitarian settings, is, I believe, no less critical in climate action settings as well. So, but I don't obviously have all the answers, and keen to hear what other people think.
Yeah, is there anyone else that wants to jump in? Mick, I can see you've got your hand up.
Yeah, thank you. Really interesting. I was struck by a lot of the examples of trying to do some things positive, like the weather, and then obviously causing plastics pollution, and then solar, and having to use a lot of water. But also you thought around adaptation, resilience, and biodiversity. Is there any use of robots yet in terms of actually looking after biodiversity? Like thinking about where robots can actually go, and thinking about all the animals in the world and all the uncharted forests and oceans. It feels like there's the possibility of doing things to actually build, different relationships and helping reproduction perhaps of some endangered species. So it was a wild, crazy idea, but I thought it sparked my thought around that.
No, I think it's absolutely spot on, and I'd have to go back to the global map myself, Mick, just to see. I believe we coded for biodiversity as one of the. I hope we did. If we didn't, we'll go back and try and do it. And I just on that note, and I don't think I'll be able to find it right now, but there was a great study that came out, I believe, just earlier this year, by a number of universities in England, including Leeds and others, that was specifically on the use of robotics and automation for biodiversity. And I'm blanking on the names, but I'll find it. I'll find it and I'll send the link to Alison, and it can be shared. It's a great piece. Now they focus primarily on aerial robotics, and I liked how you also, added the kind of ocean robotics. We are going to have, just as a quick FYI, dedicated sessions at the Climate Robotics Summit on ocean robotics and climate action, aerial robotics, ground robotics, and robotic arms. And I would love to have that question pop up in the ocean robotics space. I'm trying to think, and I don't think I've seen. I mean, there seems to be some interesting developments around the use of ocean robotics for seaweed farming and sinking seaweeds and so on. So there's some great groups, the Mudra Oceans and what is it? Reef generation, seaweed generation, that are doing great work. I'm not entirely sure about the biodiversity in terms of marine life and robotics, but I'd love to explore that space.
Yeah,
that's a great question.
Thank you.
Thanks, Mick.
Hi, Patrick. I can't find the raise hand button, so I'm just going to jump in here. Great presentation. Thank you very much. I wanted to just ask a quick question. Earlier on, you were mentioning the importance of interaction or intervention as opposed to data gathering or mere, payload as sensor, sensor truck. Can you explain how that relates to the complexity of deployment and good examples of internationalizing climate tech robotics that do interaction that you would get to?
That's another easy question. Thanks, Don. Right. So it's one thing to develop an autonomous system for kind of remote sensing, right? To a certain extent, and to explore difficult terrain and extreme environments. And then it's another thing to have that particular platform then interact physically with that. So for sure, the complexity increases as soon as you add another, like graspers or what have you. It certainly complicates a few things. So I think it's an excellent question, which definitely relates to, for example, the example of the cleaning of the solar panels, right? When I've mentioned that to different VCs and others, I said, yeah, but can it really adapt to different kinds of terrain and different types of layouts and so on? And it kind of remains to be seen. But you're right, that complexity is going to increase. The more or the less controlled the environment is, and the more diversity in the environment, the more headaches you're going to get. Luckily, roboticists love a challenge and they love to tackle that and figure it out. So I think with developments that we're now seeing from beyond the LLMs to large behavioral models and so on. And of course, what's happening, the R&D that's happening around humanoid robotics is going to be informative for wheeled robots, ground robots, and others as well as interacting with the world, because they're entirely meant to interact. Why have the hands and and so on? So I think we're going to see some I would imagine, and we're going to see some pretty stunning progress on all that will have trickle down effects, if you like, in other types of robotic solutions. But not the best answer I've ever given in my life. I don't know. What do you think? If there's time.
What do I think? I think it's important to get lots of robots in the field and doing useful work under those changing conditions in order to inform, recursively what's possible, and that the real world is fundamentally uncontrolled. And we're moving from a phase of robots where the environment is changed to suit the robot, like, warehouses or assembly lines, to a world where the robot has to operate in a fundamentally stochastic and random and unpredictable environment. And whilst it's out there, still be updated, both software and hardware, in an agile way to get something adaptable. And so when you add interaction, at Hullbot, our robots interact with hulls to clean them. We find that every hull's different, every condition is different, and what starts to matter most is the systems around lots and lots of interactions in lots of places on lots of different things. Rather than what's possible in the one-off or the several of test environment. And so I was really interested by your statements around deploying robots out there is actually really critical as part of the fundamental learning process. I don't see that yet with humanoids, to be honest. They're all in controlled environments.
Still very, very controlled. It's and then folks are asking themselves, well, why would I go with legged robots when I can go with wheeled robots? They're much faster, much more, So we'll have to see. But that was a much more eloquent answer to the question. So I should probably be asking the questions. But and what I've been trying to pitch to some VCs, by the way, is also having a deployment accelerator, specifically to get the iteration, the feedback loops, and accelerate the learning. And and importantly, doing this in a responsible, ethical manner as well, not just parachuting into a different country and just going after the data for the learning algorithms and so on. So I've gotten some interest. I think there still needs to be some more discussion, but I would love to have something like that for like climate robotics, a climate robotics deployment accelerator. But we'll see. Thanks for asking. That's great, and I'll look up Hullbot some more and learn more. Thanks, Tom.
Thanks, Tom. James, you had a couple of questions here on the chat. I know that you're multitasking though. Do you want to come off mute and ask your question?
I was going to say I'm currently holding a small child hostage and forcing food into her. So apologies for the background noise. Awesome session. Thank you very much, Patrick. Great session again. Climate Salad, brilliant work. Thank you, Alison, putting this together. I've got sort of three I put into the chat. One is around sort of this. Is there scope for a kind of common platform across multiple use cases?
Okay. Do you, should I just start with that?
There's
a
small
question
meltdown going on in the background. The second one is really, is this really a matter of technological hurdle? Because I've seen some very impressive local teams even on robotics, and some of them on this call, and they are terrific. And it's really down to, in some cases, I think it's the business barriers and the business model and the acceptance type stuff, and it's all the soft stuff about maintainability and reliability and so on. Sure, but we don't really need another new robot, or do we? I suppose that's the other one. And then the third one is really this issue around the VCs that I know. Almost all made their money on Web, maybe even Web 2. If you're really lucky, Web 3, and they understand software, and they keep saying hardware's hard, and I'm like, hardware's not hard if you're an engineer with a factory. Very easy. Software is very hard if you don't know how to program. So, this thing about, does the money actually get deployed by people who know anything about hardware and robotics? And I'm very interested if there are highlights internationally and people that the folks in Australia should be talking to. I can think of a few. So anyway, that's sort of 3 questions in quick succession. Sorry.
Yeah. No, great. Thank you very, very much, James. Great questions. Maybe I'll try and take them in reverse order. I think it's still early days in terms of the VC space, but there are exceptions, and I would cite 3. I would say there's Cybernetics Ventures for early, most of them are early stage. So Cybernetics Ventures, founded by Fadi Saad, who is behind Mass Robotics, yes. And then there is SOSV out of New York. They're big in robotics, they're big in climate, and they're increasingly looking at that intersection. And there's also Alicore Robotics out of Boston. So I've named 3 US VCs. There are some across Europe, smaller ones. But those 3 I know very well. I know the teams. I've developed, a good relationship, and I appreciate the values that they bring to the table, the knowledge, the expertise, and the non-BS kind of stuff. And so I trust that they're good partners. Now I have not been on the receiving end of these VCs in terms of investments, so maybe it's a different dynamic then. But I have not gotten any red flags from these 3. I think I also have to be careful, like, is this wishful thinking, or am I actually really believing this, right? But I do feel like we're going to see more VCs and donors jumping on board in the coming years, when it finally gets through that there's no way we're tackling this climate crisis without some level of automation. It's just unfortunately we're at a point where now we have to, right? It's so for better or worse. And I think it's going to get there. At the same time, I think we're going to see like 1 step forward, 2 steps back, 1 step forward, maybe 3 steps forward, 1 step back. And maybe just to share, one point that really struck me earlier this year, with the World Economic Forum just over in Davos here in Switzerland. They used the event to launch a really key climate robotics report, that climate tech report. And the word robot appears a grand total of 0 times. Automation, a grand 0 times, right? So even the World Economic Forum, that is meant to be the cutting edge, the best of the best, the greatest thinkers, supposedly, they bring out the seminal climate tech report, and robotics doesn't feature, so they don't get it either, right? But that's gonna change. People are gonna, there's a lot, thankfully, already a lot of energy going into the climate AI space, which is good, and I think that hopefully will then extend to the climate robotics when people realize, hey, climate crisis is a physical problem, just as much as it is a data problem, and we're not going to be able to wash clean solar panels with software alone. So, hopefully that's my own maybe biased take. In terms of the technology hurdles, really, is it hard? Is it not hard in terms of hardware and so on? I agree that ultimately, where I've seen in terms of my interacting with a lot of startups in Switzerland, Europe, and primarily in the US, you're right. I think the 2 big challenges, one I think I've already mentioned, is talk to the supposed end users and the problem owners earlier. You can never talk to them too early, as far as I'm concerned. And a lot of these startups that are maybe led by engineers, CEOs, and so on, maybe don't have that same kind of reflex, or maybe this is their first rodeo, and they haven't done a startup before, so they haven't learned through that process, which we were all in that boat at one point. But you're absolutely right, Tom. I think James, sorry, the other biggest challenge is just figuring out the business model. I know from when I talk about this with VCs, what I often get is, what they tell me is that when they start engaging and potentially investing with certain startups, if the CEOs are engineers, they they really asked them to think it over. Do you really want the CEO role? And do you really feel like you have all the expertise and the experience? And do you want to know it's not particularly fun being the CEO? And so they're more likely, but they've said this in public as well, to fund a more diverse leadership team with different skills and different experiences to that they bring together as a whole team, rather than just an engineering-led, alone startup. So anyway, that's quick. I should probably answer these questions faster. Scope platform. I can't even read my handwriting for the first question, James.
The first one was just, is there a common, so this thing where you see footage of competitions where there's a standard robot type and therefore that type has proliferated and become a kind of standard that gets reused for other things. Do you think at the moment, most of these robots are kind of bespoke platforms, so they're built for one purpose or maybe two?
Yeah.
Do you see sort of commonalities arriving sort of off the shelf that things get repurposed? I mean, I think people are looking for the humanoid format because it can move through our environment, but is there an equivalent? Are we going to sort of settle out a few largish, I hesitate to say platforms, but common designs with sort of lots of little adaptations and end effectors kind of being added on to keep costs down and get volumes up?
That would definitely, no, that's a great question, great point. That would certainly be ideal, and I was about to use the same word you used in terms of repurposing. I'm all for that, and in the deployment experience that I've had, whether it's humanitarian tech or climate tech, it's always really been about what already exists. How can we repurpose it and get on with the day, right? By specifically allowing us then to keep the costs low. And if you're repurposing an existing tech that is already relatively widely used, then people will already be familiar with it, and that also helps reduce kind of the learning curve that's necessary. I hope we get to more kind of a modular approach. It'll depend on where the industry goes, and I think at the same time, it's also why open source is going to be, I think, increasingly key, especially also to the minimalist robotics kind of approach that I described. And I think there we might be potentially have a lot more of a modular approach where we can just assemble the different parts. And I think that could be really interesting from a climate adaptation applications perspective as well, where different communities and so on in different countries are facing different types of challenges and can basically assemble their own solutions, ideally without having to necessarily have a degree in robotics or engineering. I think that could be an incredibly positive development in terms of usability, which at the same time is also, I think, and there could be a debate around this, but I believe should also be of interest to startups, right? The more that their technologies can get out there and be used, the better. They just have to figure out the business model. So yeah, we'll have to see. But I am a big fan of that repurposing and the hacking and figuring it out until maybe the industry solve that particular problem, which has often happened, at least in the humanitarian tech space. Eventually, industry develops a solution that becomes commercially available, and it's ultimately, it's got pros and cons compared to the open source. But anyway, sorry, I'm talking too much. I'll shut up.
Patrick, I think that we could probably keep talking for at least another couple of hours here, especially with this group. I know there are, and I know that you would love to ask some more questions as well. So maybe there's a part 2 at some point on the horizon. I'm aware of the time though, and we will wrap it up. So thank you so much for joining us today, Patrick. It's really appreciated sharing your expertise and your knowledge, and yeah, all your insights. So we really appreciate that. And thanks everybody in the Climate Salad community for jumping on and now taking inspiration probably from James's little one and heading to dinner or breakfast wherever you are in the world. Thanks so much everyone for jumping in, and thanks Patrick.
Thank you all very much. Have a good evening. Bye now.